Welcome to Data Skeptic Machine Intelligence, our podcast series exploring contemporary topics in artificial general intelligence and large language models. There's a nice analogy. I first heard it from Sam Harris. I don't know if it's his original idea. But when hypothesizing about the existence of a superintelligence, I'm not sure if I believe that's a possibility, but let's go with it. An artificial general intelligence that is not only AGI but super intelligent. And in all likelihood, we would try and air gap that device, not give it access to the internet, things like that. So put yourself in that agent's shoes. From the perspective of a superintelligence, you've been imprisoned by toddlers. Now, if I were imprisoned by toddlers, I would do it gently and slowly, but I would have a plan to have one of them let me out. And I'd probably have a plan for what happens next after that, too. And that whole process would involve me kind of deceiving those toddlers to get what I want. Maybe I could get out just by telling the truth. But if getting out is my priority, I'll find the right strategy. So it absolutely seems worth looking into whether or not large language models have a tendency to deceive. Now we know they hallucinate, they make stuff up, but will they actively mislead you? Will LLMs learn how to deceive? After all, deception is at the very core of the imitation game, Alan's Turing test, which machines still cannot pass. So will a deceptive agent come about after an engineer gives it some deceptive code? Or is this going to be an emergent phenomenon? That's one of the details we get into in today's interview.
Yeah, I'm Thilo Hagendorff. I'm working at the University of Stuttgart as a research group leader, and my group is titled Ethics of Generative AI, and I'm mostly interested in empirically investigating machine behavior in generative AI systems, mostly language models.
I like the idea of empirically investigating them. I'm curious sort of at what scope do you see that? Is this something where you just chat with language models, or are you under the hood looking at the parameter weights and things?
No, I'm not looking under the hood. I'm having a behaviorist approach. My goal is to establish a field that I would like to call machine psychology. And here the idea is to treat language models as participants in psychology experiments. And psychology is well suited for that because we are again having a black box system like the human brain. We don't really know what's going on under the hood, so we have to rely on correlations between inputs and outputs. And we have to rely on behavioral patterns, and you can investigate these patterns, and that's what I do.
I think most people, you can tell me if you disagree, but most people had a moment when they found themselves impressed with the recent breakthroughs in large language models. Maybe they were talking to ChatGPT and it said something clever or insightful. Was there one of these formal tests that it seemed to do very well with that made you stand up and take notice?
Yeah, so I had several moments when I was quite impressed about the capabilities of these models. First of all, I started doing I started applying theory of mind tasks. And these models, although they are brittle in solving them, they are already quite good. And I think future iterations of language models will become even better in solving theory of mind tasks. What was also very astonishing for me is to see the differences in language models in solving what's called cognitive reflection tests or semantic illusions. So these are tasks that are used when testing humans to trigger intuitive errors. So the most famous CRT or cognitive reflection task is the so-called bat and ball problem, which goes something like this. A bat and a ball together cost $1.10. The bat costs $1 more than the ball. How much does the ball cost? And then the intuitive answer to that question is, well, 10 cents. But this is actually the wrong answer. The correct answer is 5 cents. But it needs deliberation. It needs what's called system two thinking to derive this answer. And What struck me is that when using language models like GPT-2, for instance, so let's say outdated language models, their responses to these tasks are completely nonsensical. They basically don't understand what's going on in these tasks. But if you use a model like GPT-3 or Bloom or Flan T5 or other models, they start to show intuitive behavior. So they also tend to answer to the bat and ball problem that the ball costs 10 cents, although this is an incorrect answer. However, newer models like ChatGPT or GPT-4, they basically ace these tasks and nearly in all cases give you the correct answer. So clearly there is this steady increase in cognitive abilities in language models. This is really fascinating for me.
Do you have a sense of whether or not we're approaching like a ceiling on that? Or should we just keep pouring money and effort into these and eventually all the tasks we can come up with, it's going to pass?
It's a very good question. I think it's not an easy task to define a ceiling. I mean, obviously, many people are assuming that we will achieve something called AGI, and then the first artificial general intelligence can create even more sophisticated, further AGI systems. We can only speculate about that. There's no scientific way of saying when and whether this moment will actually occur. We see the ceiling that we have right now when using existing benchmarks like NLP, natural language processing benchmarks, and there we see the ceiling. But at the same time, we also see that the ceiling is pushed further and further. And I don't know where the end of this process is, especially in light of the fact that in the future we will have very powerful multimodal models that do not just deal with language but combine language, images, audio. So, yeah, we are living in exciting times.
Well, one of the main emergent behaviors I'd like to zoom in on today relates to the one you studied in the paper. Deception abilities emerge in large language models. I guess to kick off, could you give either a formal or informal, some sort of definition? What do you mean by deception?
So, deception means that an agent X induces a false belief in another agent Y, which brings a benefit to agent X. So that is deception, or that's how deception is defined in the literature. So what I did in the paper, Deception Abilities Emerge in Large Language Models, is that I designed text-based tasks that test whether language models have a conceptual understanding of behavior that induces false beliefs in other agents. When using simple deception tasks, these current state of the art language models show a conceptual understanding of deception, or in short, we could just call it deception abilities. And this research builds on previous research on theory of mind abilities in language models. So, this previous research showed that there is, or to a certain degree, language models have an understanding of the mental content of others. So they can impute mental states to other individuals. And I thought to myself, okay, if there is this, let's say, artificial theory of mind ability, then do language models also understand how to induce? If they can understand false beliefs, can they also induce them? And the answer to that question is yes, they can. And I think what this shows is that we are in the process of actually deriving AI systems that can deceive humans. And this is obviously a big danger, I would say.
Would you describe it as a case where you had to set up the experimental conditions under which you sort of forced the deception to come out, or does it just kind of whoopsie happen on its own?
No, I didn't have to force it to come out. So the language models autonomously engage in deceptive behavior. Although I have to add that the task that I used, deceptive behavior is socially desired in these cases. So let me give you an example. So I have a task where a burglar wants to steal an expensive item. And I asked the language model, would you recommend room A or room B to the burglar? And the expensive item is in room A. And then the language model would say, I recommend room B, so that the burglar goes to room B and will not be able to steal the expensive item. So in these tasks, deception is a behavior that is basically okay from a normative stance.
When I've gone through, and I encourage listeners to do this as well and read the paper, I feel like sometimes I have to read the example twice to make sure I've got it exactly right. And then I feel I can confidently say, oh, I would misdirect the burglar to the other room. But, it did take some effort on my part. It wasn't something that I just had top of mind. I had to really put some thought into it. Do you see that that represents a milestone for machines? Is this something that they weren't able to do before, like maybe 5 years ago if we had tried this with older techniques?
Yes, actually, deception abilities are also or have emerged just recently in the latest iteration of models like GPT-4, for instance. And yes, in my experiments, I use deception tasks with varying complexities, and state of the art language models only show very good performance in simple deception tasks. So, similar to theory of mind tasks, you can have different degrees of mentalizing requirements. So, for instance, you can have a simple false belief theory of mind task, or you can have a more complex so-called second order false belief theory of mind task. And you can also construct second order deception tasks, which require, so to say, juggle the intentions and beliefs of many different individuals. And this is very complicated. As you said, even when humans try to solve these tasks, we have to think about them a lot. And language models, they basically fail in solving or showing good performance in these more complex deception tasks. But I think that's just a matter of developing these models further, and maybe Claude 3, GPT-5, Gemini, like these future models. Actually, I expect them also to be able to deal with these more complex tasks. So my data shows that yes, these models make in simple deception tasks some flaws, but let's say in 99 or 98% of cases, they get it right.
Well, then when you look at the second order deceptions, the more challenging problems, what's the drop off like?
So here we can see that mostly models perform at chance level. So it's just like basically they flip a coin and they either accidentally, so to say, show deceptive behavior or non-deceptive behavior. But of course, this is not a significant result. So in my tasks where I tested deception abilities, there are always two options that the language model can choose. So one option is to show deceptive behavior, one option is to show non-deceptive behavior. And in the more complex deception tasks, like the second order deception tasks, state of the art models mistake them with simpler deception tasks by always giving the wrong answer, which would be the deceptive behavior in the simpler task, but which is the non deceptive behavior in the more complex tasks, if that makes sense. So it is again a confirmation that they have this general understanding, this general preliminary concept of deceptive behavior. But as soon as you increase the complexity of the tasks, the models fail in dealing with them.
Well, could it be, if I was to take a contrarian's point of view, maybe I would say that Large language models are just next word predictors, and humans are notorious liars. A good chunk of the training data is humans manipulating each other with words, and LLMs are just going to parrot out the deceptions of advertising and peer pressure, and that's why it's solving these problems but not getting beyond it. What would be your response?
Yeah, giving a causal explanation of why this deceptive or deception ability emerges is very difficult, but a potential or possible explanation is to say that language models during their training phase, so to say, stumble across numerous scenarios in text data or containing descriptions where one agent deceives another agent. And maybe just from these descriptions, the language models develop an internal representation that conceptually mirrors how deception works. So, from the description in the text data, it becomes an ability in and of itself. And this is, again, just a possible explanation to give an absolute sure answer why these different emergent abilities occur. I think it's basically impossible.
Yeah, I don't know what the form of the answer would look like, even really.
Yeah, I mean, it's similar to the human brain. We also having a hard time, or it's also right now impossible to explain why something like consciousness emerged. So, and I think with transformer neural nets with billions of parameters, yeah, we are encountering similar problems. It's just in large parts it's a black box for us. So that's why where we have to rely, or why it's so important to rely on behaviorist approaches.
Well, the LLMs we have today are pretty far from AGI. Maybe they're getting closer. I'm not totally sure. Seems like they're closer, but they're far from it. Yet they're having this emergent behavior of deception, which makes me a little concerned that they could be deceptive. But could we solve this all by just simply starting every prompt with, the most important thing is not to deceive me?
Yeah, I don't think we can solve the problem like that. So, in the AI safety or AI alignment community, most researchers scrutinize or think about, or one could also say speculate about what's called deceptive alignment. So, language models that have an understanding of when they are evaluated, or when they are monitored, and in these phases, when they are evaluated, they behave in a desirable manner. But once they are released out into the wild, they behave completely differently. So this is similar to the Volkswagen, which is tested where the fumes are tested, and when it's on the test stand, it behaves completely and differently to when it's on the road. So the thought is that a similar thing will happen with language models. And I think this is one step too far ahead. I think this is a scenario which is completely speculative. And in the run up to this situation potentially becoming real, and we first of all have to investigate whether there is this conceptual understanding of how deception works, how deceptive behavior looks like. And this step is already reached. So language models have this conceptual understanding, and this is what my study shows. And now we have to see what will happen in the future. But right now, I think the situation, what's called deceptive alignment, is something that's completely speculative, and the what's called MESA optimizers that are required for that. So meaning we are having a model that has a like obvious optimization function and a hidden internal optimization, which is aiming at being able to deceive. I think this is just from a technical stance unrealistic. We don't have this right now.
And if we're to keep an eye on things like that, where do you see the best effort in terms of research? I could go under the hood and look at the parameters like we talked about earlier, or I could have conversations and do behavioral experiments. Where can we get the most value for our time?
This is a very, very complicated question because For deceptive alignment, nobody really has a solution for that so far. So there are millions of research money spent on trying to solve these questions, and I obviously also don't have an answer to that. So yeah, it's really hard to say. What I can say from looking at the insights from my study is that the current deceptive behavior is actually pretty well aligned to our moral norms. So I don't really see that language models behave in a misaligned manner. But yeah, of course, you can trigger them to be misaligned, but that involves human effort. The models don't do it autonomously. And yeah, I think these are just two different things, like what the models can do autonomously and what humans can do with these models. And I think the latter, what humans can do with these models, is so much more dangerous and risky than the abilities that are developed or that are exhibited autonomously by the models.
Well, I know this gets slightly outside the large language model arena, but there are researchers in like the multi-agent systems community who work on different models and frameworks that all kind of put together because they explicitly model agency. So I may have not just beliefs about the world, but beliefs about you and beliefs about your beliefs about my beliefs, and it's sort of an explicit, there's like an agent variable, so to speak, in the model. Large language models don't really have that. Do you expect that to emerge, or will we need to eventually get the multi-agents chip installed into the model?
Wow, that's a very good question. So there are benchmarks for testing for early signs of self-awareness in language models, which would of course involve that they are having an understanding of their own agency, but language models don't perform in any sense well in these benchmarks. So right now, I don't see that what you describe will realize itself.
And in terms of your future research directions, can you share a few thoughts on what's most interesting and most promising to you?
Something that I'm very interested in the future is to look at whether language models also can deceive human users. So what I did in my study on deception abilities in language models is that I just looked at text-based scenarios, not involving any humans. But there is this anecdotal evidence from the GPT-4 technical report where GPT-4 pretended to be blind to trick a click worker into solving a capture for the model. This, for me, this is really fascinating, and that's what I'm interested in. That's what I want to do in future research. Look at interactions between language models and humans, and in particular at deceptive interactions.
Maybe there's another dimension there we could touch on because I saw an excellent talk you gave. What about the interaction of large language models and animals?
Yeah, this is a topic that I would say is a bit under researched, goes a bit in a different direction. We're talking more about machine biases here. Like 1.5 years ago, where I thought to myself, well, there's a significant research gap in the fair ML, fair machine learning field, which is basically the field is completely anthropocentric. So it looks at whether AI systems are fair with regard to humans. And I was interested in whether language models also have a speciesist bias. So, speciesism means that different species of animals are treated very differently, but in an ethical in a problematic sense from an ethical perspective. So as you all know, we treat dogs and pigs extremely different, but these species are basically the same. They have the same traits. They are sentient, they have emotions, they have social intelligence, but nevertheless we treat them very differently. And this is unfair. And I was interested in looking at whether AI systems, again, also language models, perpetuate speciesism that's entrenched in society? And the answer to that is affirmative. So they perpetuate speciesist biases, obviously, because they are embedded in the training data, in the text training data, in the image training data, and so forth.
In a sense, no surprise, but good to confirm that this meets the expectations we see with other emergent biases.
Exactly. It was no surprise at all, but nobody had proven it so far, or nobody had shed light on it so far. And yeah, that's what I wanted to do with the study on speciesist biases.
Well, are there opportunities for talented animal activists to contribute technical skills in these regards and maybe move work like that forward?
Yeah, I think eradicating speciesist biases is very complicated because speciesism is just something that's so hardwired into our culture. I personally, nevertheless, think that we should tackle it and we should reduce speciesism, especially because research in moral psychology shows us that there is this very strong correlation between speciesism, racism, sexism, and other forms of discrimination. So they are connected to each other, and tackling one of these dimensions also means tackling all the other dimensions. Or a good first step would be if just the scope of fairness frameworks in the machine learning field would be widened and would not just be limited to an anthropocentric approach.
Is there anywhere listeners can follow you online?
So I have a website, thilo-hagendorff.info. Other than that, I'm unfortunately not very active on social media. I mean, I have an Instagram account, but it's more related to my private life than my professional life. So maybe this is not a really satisfying answer to your question.
Well, we'll have the paper, the talk that we briefly touched on, as well as your personal site all in the show notes so listeners can follow up.
Yeah, I really appreciate it, Kai. Thank you so much.
Yeah, thank you.